All right. This week we are going to look first at just several types of classical statistical inference, things that we've really been doing. We're going to give a little more uh, definition to, and then talk about confidence intervals, and then go from there. So, if we want, say we want to get an idea about how, or we wanted to get an idea about how the presidential election would have unfolded in 2016, many people were trying to understand what was going to happen. And if more than 120 million people are expected to vote, we don't have time to contact all of them, right? So what we do is we tend to poll samples of the population, right? And we use their responses to infer results of the population, the results of the population as a whole, to try to model, predict, right, what's going to happen. So this process of taking in data, analyzing it, and inferring something goes way beyond polling. All right, it just happens to be one of the most common examples or popular examples. So, for example, scientific studies, marketing, all right, social sciences, and medicine all use different forms of statistical inference. All right, and one of the most important things that we have to recognize here is that there is some measure of uncertainty in our world. And we try to model it, measure it, quantify it so that we can best decide what to do. All right, and statistical inference coupled with probability, all right, measuring the likelihood of an event occurring, are our best tools to do so. And so some of the inferences we're going to talk about, right, can become a matter of extreme importance. All right, and we want to look at how we can apply some of these three different types of statistical inference and where we might see them in the future, or we've seen them in the past. So type 1, the first type of statistical inference we're going to talk about is where there's a fixed collection of data, but we only know a sample of it. And our goal is to then infer data of the entire population from analyzing that one sample. All right. So again, the goal right here is repeated from our above statement, right? But examples of this include polling for elections, right? Our example from the top of the page. What about determining distribution of heights of female adults in Canada? All right, that would be another example of where we would take a sample of the population, right? There's a fixed collection of females in Canada, right? But we would take a sample of it, we would look at the distribution there, and we would try to infer, right, the data of the entire population from looking at that one sample, right? And one of the other ones that we're going to come back to is testing blood for cholesterol, testing your blood for cholesterol. We gather a sample, all right? Likewise, if we're testing for blood sugar levels, we gather a sample, all right? And we infer something about the entire population, your entire blood stream, right? And the presence of cholesterol or sugar throughout your entire body. Okay? Included with these, we're going through this fairly quickly because I just want to introduce these ideas, and we'll get on to stuff in terms of articles and Lorenz curves in a little bit. But I also mentioned some of the important concepts that get used there. In other words, tools we've already talked about to help us understand, all right, and make these inferences, understand the data and make inferences. So these are all good things to have, or important things, good things to have in mind as you're looking to make statistical inferences. Right, mean, shape, spread of a random sample should resemble the entire population, what we might call a representative sample. Right? More data and larger random samples will drive analysis to be more representative of that entire population. Right? And we can give confidence measures concerning how close our data is to that of the whole population. Right? We're going to come back and talk about that in a little bit. The second type of statistical inference we're going to look at, all right, is where we have some fact of reality that is unknown. All right. So what we do is we employ statistical analyses to try to determine what is most likely to be true. Okay? In other words, there is a fact about reality. However, we do not possess, right, the knowledge to know what the case is, what the characteristics are, what the likelihood of a situation is, whatever. All right. So what we do is we employ statistical analyses to determine what's most likely. So one of my favorite examples is the Federalist Papers, or are the Federalist Papers, right? And what happened was Alexander Hamilton, James Madison, and John Jay, and a few others there was a collection of essays called the Federalist Papers, and many of them were known to be written by certain people. In other words, they were attributed correctly. However, there were 13, I believe, papers that had unknown authors. And so what they did was they compared, all right, the two people who wrote the most Federalist Papers, Hamilton and Madison, they compared their writing styles to those uncredited essays. So, for example, I believe Hamilton used the word upon 7 times out of every 1,000 words, right? Whereas Madison used it only once. It was Madison or Monroe, I can't remember now, but once per 1,000 words, right? And along with some other language and word choice, as well as sentence structure, I believe, they were able to determine that it's most likely, in other words, they are quite confident that Hamilton had written 12 of them, and the other individual, Madison or Monroe, had written the other ones. All right. So, what we want to do, all right, is when we're looking at this sort of situation, I'll say what we want to do. One of the other cases, it was Madison, for the record. I had to go on a deviation to look it up. James Madison was the other individual. Other than the Federalist Papers, now that I'm done with that little tangent, another example of this is a criminal trial. All right. In theory, the jury will not be certain, or the judge will not be certain about whether the defendant committed the crime or what the reality of the situation that occurred was. All right. But statistical analyses are performed. All right. Different testimonies are gathered, and only if it is unreasonable that the evidence presented would exist, assuming the defendant was innocent, does the jury find the defendant guilty. So this is an idea of a null hypothesis, right? In our true criminal justice system, right, we are supposed to, right, presume innocence until proven guilty. In other words, proven guilty beyond a reasonable doubt. Only would this evidence exist, right? Well, this evidence is unlikely to exist. It would be unreasonable for it to exist if the defendant is innocent. Then do we say the defendant is guilty? And this idea of statistical significance comes in there, all right, in a much less rigorous way, because there is a very human element to a trial, for example. But, all right, one of the key sort of capturing quotes about this sort of thing in terms of the concept is, if the world is a certain way, this type of statistical inference, if the world is a certain way, we expect certain data to reflect reality. Right? That's what I always think of when I think of this type of statistical inference. Okay? All right, the final type that we're going to talk about here is where reality contains some probabilistic feature, and what we do is we use a random sample to determine what the chances are. Now that's a little different than what the first type of statistical inference was, right? The first type of statistical inference is we had some sort of fixed collection of data, and we only know a sample of it. And so we want to infer data of the entire population. Well, here, instead of inferring data of the entire population, what we're really doing is we're saying, all right, reality, our world, life, contains some probabilistic feature. And we want to take a random sample to try to determine what the chances are. Okay? Now, this is quite different, right, than what we did before. For example, the example I like best is medicine efficacy trials. All right, if there is a new drug, all right, they undergo random trial testing periods, all right, where their effectiveness rate is determined. All right. In other words, how frequently, what is the likelihood that this medication or this chemical, right, will produce the desired result? Okay, maybe it's 70% effective, maybe it's higher, maybe it's lower, all right? But that sort of inference, all right, is taking some unknown about reality, okay, and trying to determine what the probability is, what the likelihood of something occurring is, right? So we can apply this, it's similar to the second one in that we can apply a method that mirrors sort of our criminal justice system in a slightly different way. We presume a hypothesis. So, for example, spun pennies, when you spin a penny, there's a 50% probability of landing heads up. All right, and we can test whether the data we find would be unlikely if this hypothesis were true. So now notice that here we're trying to determine a probability of our in reality, right? Some probabilistic feature of reality. Whereas over here in the criminal trial, all right, situation, there is clearly, right, some facts of whatever the case was. In other words, this person either did or did not commit the crime, right? It's not a probabilistic feature that that event occurred. One of two things happened, right? Whereas down here, all right, the probabilistic feature is that spinning a penny, all right, it might show up heads sometimes, it might show up tails sometimes, all right? There's some sort of probability there. And measuring the strength of evidence leads us through all of these, really, but it comes in on this one, leads us to this idea of statistical significance that we've talked about before. Right? I just want to make one last comment. I know I'm sort of in a hurry, but I want to make one last comment about the cholesterol testing from type 1 of our statistical inference. All right. And so when we get blood drawn to test for cholesterol, a good question would be, what statistical inferences are taking place? Right? And I like to use, again, this phrase, representative sample. Right? In other words, we're assuming that it is a representative sample of your entire bloodstream, right? Your blood content throughout your body, right? Cholesterol content in your blood. Right? So my question is, and what we're going to get back to later, is that why don't we, right, drain all of our blood, right? Do some sort of massive dialysis transfusion type process where we measure all of the blood, right? Why in cholesterol do we take a different sized vial, a different sized sample, we'll say, than with blood sugar? Right? Does it involve the size of those elements, right? Really, those minerals and stuff, or does it involve? We're so close.